All right, so the first thing that you need to do today is go back to our notes and you need to make sure that you complete the electrical safety information. It's pretty straightforward, there's not much to it. And then what we spent the class doing today is going through the math portion on there. So I took all those math problems that are in your slides and did them in the SMART so that way we could work through them together. In every single problem, it's going to give you the formula. The biggest thing is to remember watts equals volts times amps. All right, so the very first problem you have, 220 volts, uses 15 amps. How many watts will this use in 1 hour? Okay, so all you have to do is plug in your numbers. So W equals 220 times 15. And W is going to equal 220 times 15. So we got a 0, we got another 0, we got a 3, 3,300. I think that's right. Let me check. My math has been off here today, man. It's been one of them long days. You know, sometimes you get them long days and you're just trying to do stuff, but everything you do just kind of backfires on you. So today's kind of been one of them days. So 3,300 is our answer for this. All right. Problem number 2, 120 volts pulls 20 amps. What is the watt rating? So once again, W equals V times A, right? So W equals 120 times 20. When you multiply those two together, you get 24 with 2 zeros. So once again, this is all very, very straightforward math. All right. Our third problem, the 120 volt sander is used for 3 hours and uses 10 amps of power. Right. So we have our formula, watts equals volts times amps. So all we're going to do is plug in our numbers. W equals 110 times 10. When you multiply those together, you get 1,100. Now, look, that is not your answer. And the reason why is because of this little thing right there, the 3 hours. So you have to multiply it by your total hours. So 1,100 watts times 3. Your answer is going to be 3,300 watts. Right? So make sure you pay attention to the hours that are on there. On this one, once again, it's going to have the formula for you. So it's amps equals watts divided by volts. So all you do is you take the 2,000 watts and the 120 volts. You divide those two together and you get 16.67 amps. 2 decimal places is all you need. All right, 2 decimal places. All right. This next one is pretty straightforward as well. Once again, amps equals watts divided by volts. So we have 3,300 watts, and we divide that by 220 volts. And that is going to give us 15 amps. Don't like the way my 5 looks there. So it's going to be 15 amps. Once again, very, very straightforward math. So a grinder pulls 20 amps and uses 4 kilowatts. How many volts does it require? Okay, so volts equals watts divided by amps. Now, if you look at this problem, we have our amps, but we don't have watts. We have this thing kilowatts. You cannot use kilowatts in our problem. So in order to convert watts to kilowatts, right, you have to multiply by 1,000, right? Because kilo is 1,000. So basically what that says is 4 1,000 watts. So when you multiply 4 by 1,000, you get 4,000. And now we can do our problem. So now we have 4,000 watts divided by 20 amps. And that is going to give us 200 volts. So just pay attention to your units. Make sure they all match up with what the formula is asking. Number 7, once again, amps equals watts divided by volts, okay? The thing about this one is it's not 100 watts. If you notice, we have 5 100-watt light bulbs. So we have to have the total watts. In order to get the total watts, you add all that together, right? So 5 100-watt light bulbs is 500 watts. Now we can do our problem. 500 divided by 120 gives us 4.17 amps of units. Cost. Cost is very straightforward. You take the cost per kilowatt hour times the number of kilowatts, and you multiply that by the hours that the item or items are used. In this case, we have 12 cents. We have 2 kilowatts, and we use it for 10 hours. So multiply that together. That gives us 0.12 times 2 times 10. The most important thing is make sure, right, we're dealing with cost. So make sure your answer's in cost. $2.40, right? Once again, cost equals the price per kilowatt hour times kilowatts times hour. So all you have to do is plug it in. We have kilowatts, or the price per kilowatt hours. We have the kilowatts, and we have the hours. So all you have to do is multiply those together. And that gives us 0.80 times 3. So our cost equals, once again, $2.40. All right, the cost per kilowatt times kilowatts times the hours of use. So if you're looking at this problem, and this is the last problem that we have, all right, we have the cost and we have the hours, but we don't have the number of kilowatts. So how in the world can we find the number of kilowatts in this problem? Well, if you go back to our original problems, we know that watts equals volts times amps, right? So we know W equals V times A. We know that, right? So now we can figure out our watts. So our watts equals 220 times 30. So now we know we have 6,600 watts, but we're still short. If you notice, our problem is calling for kilowatts. So how do we convert watts to kilowatts? Okay, so in order to convert watts to kilowatts, right, watts to kW, you have to divide by 1,000. So this 6,600 watts is divided by 1,000. And that's going to give you 6.6 kW. Now we can use this and there and go ahead and find our cost. And when we do that, our cost is 15 cents times 6.6 times 1 hour, and that gives us a grand total of 99 cents. And that's how you do this math. Now, there is an electrical worksheet that is in Canvas that you need to complete today. So some of the questions is asking for the amount of watts in 1 hour and then in, say, 2 or 3 or 4 hours. So if the question is asking for 2 answer choices, please make sure you put 2 on there. And that is what you have to do today. If you have any questions, be sure to email me. And if you don't, I will see you in class tomorrow.